the title of our project is Maze Solver Bot. Basically, it is an autonomous bot. Given a maze and a start point and end point, it explores the maze till the end point. After that, it traces back through the optimal path possible. In this, we implemented 3 algorithms. One is wall follower incorporated with dead end filling algorithm. The second one is A-star algorithm, and third one is SEMA algorithm. Coming to the work division, me and Ashok have done the bot sensor work and implementing wall follower algorithm. Salman has done A-star algorithm, and Vasu has done SEMA algorithm.
Coming to the interesting algorithms part of the project, we have implemented 3 algorithms, namely wall follower, A-star and SEMA. So we will go one by one. Wall follower algorithm. So what it does is, it chooses a wall to follow in the maze, goes by that wall and reaches the end state. After reaching the end state, it resolves the string state using the dead filling algorithm that we implemented and traces back to the start state through the optimal path possible. And coming to the next algorithm, it is A-star algorithm. So what A-star algorithm does is, it gives heuristic values to the different nodes and takes the A-star algorithm, implements it and finds the optimal path by exploring all the maze. So the heuristic that we are using in the present A-star algorithm is the Manhattan heuristic, which is the x distance plus y distance to the goal node. The other algorithm is SEMA algorithm. So what it does is, it explores the whole maze, choosing a random direction at every junction, and what it does is, if a path is traversed twice, then it will eliminate the path in the optimal path, such that we will get one optimal path and it will trace back in the optimal path from goal to start node. So as we can see, all the 3 algorithms explore the maze first and then they trace back in the optimal path. It can also be designed as the bot will start from start node again and travel through the optimal path to the end. This is done by saving the maze into the robot.
For a fast, clean and errorless implementation of a maze solver, it is important that we have a bot tailor made for the job. The non-availability of such a bot was the biggest challenge we faced. The problems, the first part of the project was to make the bot follow the black line perfectly. The bot is supposed to travel through the black line, recognize each intersection and do the necessary action. But the bot had problems detecting the black line when it traveled very fast. The motors had error values too. We then recognized that these problems can be solved by implementing error corrections and right delay values. The algorithms of the maze solver that we implemented also needed good troubleshooting, and it took a lot of our effort.
Before going into the future prospects of the whole project, I wanted to talk about the limitations of our project first. So what our project basically does is solve a 2-dimensional maze. So in a practical scale, it has no value at all. So what further projects can be taken up using this model is that you can set up more and more increasing difficulties gradually, layer by layer, so that it can finally be of use to someone. So for example, put in a 3D maze so that it can solve using the walls rather than the lines, and then you can implement the rougher terrain, and then you can finally implement into the location wherever you want to use the bot. For example, bomb diffusing and such situations, this bot comes in helpful.
This is the simulation part of our project. It is a simulation of maze solving on computer based environment called player stage. We simulate the algorithms we implemented. First, the A-star algorithm. This is our maze, and this green object is our bot. So I am implementing A-star on it. As you can see, the bot first explores the maze. It it goes to each node as per its heuristic value. We basically implemented Manhattan heuristic in this. So now it is it is reaching each it is going to node as per the minimum value of the heuristic. So after it is reached, it sends that node into a closed list, so it won't be visited again. Whatever nodes are open, once the node is sent to the closed list, the children of that node are sent to the open list. So the nodes in the open list are visited now. Now it reached the final destination, so it is retracing back to the start position in an optimized path. As you can see, it doesn't take, it just goes through the optimized part, doesn't go to other deviations. And it finally reached. We are implementing wall follower algorithm. As you can see, the bot started exploring the maze. It follows the left wall. Whenever it meets a junction, its first preference is to take a left and then take a go straight, or and finally to take right. Now as at this junction you have a chance for both left and right turn, it goes for left turn. It reached the goal state now. Thank you.